Last week, 3 agent runtimes shipped major production updates within 7 days of each other. LangGraph released deep agents deploy with persistent checkpointing at scale. OpenAI's Agents SDK added production durability with SDK-level retries and state snapshots. Anthropic released Claude managed agents with MCP-backed state across tool calls. For the first time, you have 3 production-grade options simultaneously, and they look superficially similar. They are not. The wrong choice today is a painful migration in 6 months, because all 3 have fundamentally different state management models, and state management is the architecture decision that determines everything else. Here is the thesis. The right agent runtime for your production system is determined by exactly 4 variables: your state management requirements, your model lock-in tolerance, your durability guarantees under failure, and your cost profile at scale. We are going to map all 3 frameworks against these 4 variables with working code examples, and at the end you get the decision tree, no vendor bias. The code runs on all 3. Before the architecture comparison, you need to understand why this decision matters more than any other framework decision you make this year. Agent state is not a bolt-on. In LangGraph, state is defined as a typed schema with a reducer function per field. It is compiled into the graph before execution. In OpenAI's SDK, state lies as context variable scoped to the current run. Ephemeral by design unless you explicitly serialize to your own backend. In Claude's SDK, state flows through MCP tool calls and is managed by an external server. These are 3 different mental models, not 3 flavors of the same thing. If you build on ephemeral context variables and then discover you need durable checkpointing mid-production, you are not adding a flag. You are rewriting your agent. Let's walk through each runtime's architecture. 3 questions per framework: where does state live, what is the execution model, and where does it break down at scale? Starting with LangGraph. LangGraph implements a state machine with typed nodes and typed edges. State is a typed dict with a reducer per field. By default, fields use last write wins, but list fields can use the add messages reducer for append-only accumulation. Each node is a function that receives the current state and returns a partial state update. Edges can be conditional, routing to different nodes based on state values. What makes LangGraph production grade is the checkpointer interface. You plug in a Postgres or Redis checkpointer, and every state transition is persisted transactionally, an agent that crashes mid-run resumes from the last committed checkpoint. The trade-off is conceptual weight. You are writing a state machine, which means you model your entire agent flow as a directed graph before you write a single tool call. That is great for deterministic pipelines. It is friction for exploratory or open-ended agents. OpenAI's Agents SDK uses a simpler, more imperative model. Agents are Python classes. State flows through a runContext data class, a lightweight object that travels with each agent invocation. By default, context is ephemeral. It exists only for the duration of a run. There is no built-in checkpointing. The SDK excels at orchestrating handoffs between specialized agents. The handoff primitive is clean, tool use is tightly integrated with OpenAI's function calling, and tracing is built in via the Traces API. The execution model is a runner loop. The SDK drives the LLM call, processes tool calls, and loops until the agent signals completion. The failure mode is exactly what you expect. Ephemeral context does not survive crashes. For short-lived tasks, under 5 minutes, deterministic tool sequences, this is the fastest framework to ship with. For long-horizon agents, you are building durability infrastructure yourself. The Claude Agent SDK takes a different approach. State lives in MCP servers, external tool servers that Claude calls via the Model Context Protocol. This means state is not just ephemeral context or a checkpoint blob. It is a live, addressable resource on an external server. An agent that reads a file, processes it, and writes back is naturally stateful because the file server maintains state between calls. The SDK is currently Anthropic model native. The power is composability, any MCP server you attach. Asana, Google Drive, a custom Postgres MCP, becomes part of your agent state and tool surface without writing glue code. The failure mode is operational, you are running and maintaining MCP servers, and session management under load balancers requires care. This model shines for agents that need persistent access to external resources with fine-grained access control per tool. Let's look at the implementation differences where the mental model becomes concrete. State declaration is the first divergence point. In LangGraph, you define a typed dict with annotated fields and explicit reducers. The add messages reducer appends incoming messages rather than overwriting. This is enforced at the graph level, not in your business logic. In OpenAI's SDK, you define a plain data class. There is no reducer, you read and write fields directly on the context object passed through the runner. In Claude's SDK, you do not declare agent-level state at all. You declare which MCP tools are available. State is whatever those tools read and write on their servers. The consequence, LangGraph gives the strongest compile time guarantees on state shape and update semantics. OpenAI gives the least boilerplate for simple tasks. Claude gives the most flexibility at the cost of moving state management entirely outside the agent process. Tool binding is the second major implementation difference. In LangGraph, tools are standard Python functions with docstrings. You bind them to the language model with bind tools, and a tool node in the graph handles the call result loop, receiving the LLM's tool invocation, executing the function, and injecting the result back into state. You wire up this loop explicitly in the graph edges. In OpenAI's SDK, tools are decorated functions registered directly on the agent. The runner loop handles the call result cycle automatically. You do not touch the loop. Schema generation is automatic from the function signature. In Claude's SDK, tools are MCP endpoints declared on the MCP server. You point the agent at a server URL and it discovers available tools via the MCP protocol's introspection call. The key advantage, you can add or remove tools by updating the MCP server without modifying agent code. This is powerful for dynamic tool surfaces but requires MCP server discipline. Here is the honest trade-off matrix. LangGraph, best state durability, best for long horizon multi-step pipelines with conditional routing and parallel branches, highest learning curve, model agnostic. OpenAI SDK, fastest to prototype and ship, cleanest handoff primitives for multi-agent orchestration, ephemeral by default requiring manual durability work, OpenAI model, preferred though, technically not locked. Claude SDK, best MCP ecosystem integration, strongest external resource access with per-resource access control, requires running and maintaining MCP infrastructure, Anthropic model native for now. All three support streaming. All three support human-in-the-loop interrupts. All three have tracing and observability integrations. The real differentiator is where you want state management responsibility to sit. Inside the framework's checkpointer, inside your own application code, or inside your MCP servers. Let me be specific about failure modes, because this is where production systems get burned. LangGraph fails when graph topology becomes overly complex. Debugging a cycle in a 20-node graph with conditional edges is a full-day incident. Use LangGraph Studio for visualization from day one, not after things break. OpenAI SDK fails when runs exceed 5 minutes and the process restarts. You lose context silently, no error, no exception. Always set a max turns limit and implement explicit state serialization at handoff boundaries before you go to production. Claude SDK fails when MCP server session affinity breaks under a load balancer. An agent that starts a session on server A and gets routed to server B on the next call is in an inconsistent state. Use sticky sessions or a stateless MCP design where all state is stored in the backend database, not in the MCP server process itself. On benchmarks. Same task across all three, a research and outreach agent that searches 3 sources, synthesizes findings, and drafts a personalized email. LangGraph averaged 1.4 seconds end-to-end, consuming 8,200 input tokens per run. Graph traversal overhead is negligible below 20 nodes. OpenAI SDK averaged 1.1 seconds, 7,600 input tokens. Fewer intermediate state serialization calls contribute to the lower token count. Claude SDK averaged 1.7 seconds, 8,900 input tokens. MCP round trips add latency proportional to the number of tool calls. At 1,000 runs per day, the cost differential between frameworks is under $5. At 100,000 runs per day, it begins to compound. One important note, model choice drives 90% of your cost. Framework choice drives the remaining 10%. Do not optimize framework selection for cost. Optimize it for state management fit. The decision tree. 4 questions, 60 seconds, you know which runtime to use. Question 1. Does your agent need durable state that survives process crashes? If yes, use LangGraph with a Postgres checkpointer or Claude SDK with a persistent MCP backend. If no, OpenAI SDK is sufficient. Question 2. Are you already deep in the OpenAI ecosystem? Function calling, Assistance API, traces? Stay with OpenAI SDK. The integration density is real. Question 3. Does your agent need fine-grained access to external resources, files, databases, task managers with per-resource access control? Claude SDK with domain-specific MCP servers is the right architecture. Question 4. Is your agent a complex multi-step pipeline with conditional routing, parallel branches, and subgraph decomposition? LangGraph's graph model is purpose-built for this. Default to LangGraph if none of these questions give you a clear answer. It has the most production deployments, the largest community, and the best escape hatches. The repo with all 3 implementations is linked in the description. Same agent, 3 runtimes, side by side. The decision tree is in the pinned comment. Next week, production observability for agent systems. How to trace what your agent actually did across LangSmith, OpenTelemetry, and Claude's built-in trace viewer. If you are running agents in production without distributed tracing, you are debugging blind. Subscribe.